Good morning, students. Today I will explain you hybridization involving d orbitals. In my last video, I explained you hybridization sp, sp2 and the sp3 hybridization, and also in the case of the carbon which form the double bond and the triple bond. Now, in the case of the d orbital, that is, in the elements of the third period in the periodic table, they also show the covalency more than 4, that is 5, 6 and 7. Then how this covalency 5, 6 and 7 can be explained? Now, in the case of the elements of the third period, d orbit is very important and plays a very important role in the formation of the covalency. Now, this d orbital hybridization can be explained very easily by taking the example sp3d hybridization, that is 1s electron, p3 electron and the d electron. If we take the example of the PCl5, whose atomic number is 15 and configuration is 3s2, 3p3, that is 3s, 3p. Now in ground state, it has 3 unpaired electrons in the p orbit, so it can show 3 covalency, that is in the case of the PCl3. But in excited state, 1 electron from the 3s promoted to the d orbital. Now here if you see 1 electron in the 3s, 3 electron in 3p and 1 electron promoted to the d orbital, that is sp3d. Here in excited state, all the 5 orbitals they hybridized to form the 5 orbital of the equivalent energy, and these 5 orbital they form covalent bond with the 3p of the chlorine atoms. So here chlorine atoms with the 5 electrons, that is 5 hybridized orbitals. So in this way it forms the PCl5. Now in this case if you see, it is a trigonal bipyramidal geometry. How we will explain the trigonal bipyramidal geometry? In this case, 3 orbits of with chlorine, they form the equatorial, and the 2 orbitals they form the axial bonds. Here, in equatorial bond, angle between the PCl, that is 120, and in the case of the axial bond between PCl, it is 90 degree. If we see, the length of the axial bond is 219 and the equatorial bond is 204 meter. Now this length of the axial bond is more than the equatorial bond, means due to the repulsive force, the bond length of the 2 axial bond is more than the equatorial bond. So due to this axial bond is a weaker bond and it form a trigonal bipyramidal geometry. This is how to explain the 5 covalent bond in PCl 5 in the where the involvement of the d orbital takes place. So it is sp3 d orbital hybridization. Now if we take this next example, SF6, here it is sp3 d2 hybridization. In the case of the sp3 d2 means 1 orbital of s, 3 orbital of the p and the 2 orbital of the d, they hybridized. If we see the ground state configuration of the S is 2s, that is S contains 2 and the P contains 4. When it is excited or in excited state, one electron from the S and the one electron from the P, that is promoted to the d orbital. Now in excited state there are the 6 orbitals. They hybridized to form the 6 orbitals, that is 6 hybridized orbital with equal energy, and this hybrid equal energy orbital, they overlap with the 2 p orbitals of the fluorine to form the SF6. See, the point is that one electron from the S and the one electron from the P in excited state promoted to the d orbitals. Now here are the 6 orbitals. They hybridize to form the 6 equivalent of same energy orbitals which overlap with the 2 p orbitals of the fluorine and form the SF6. Now this how to explain the hexavalency in the case of the SF6. Now in this case, it is a octahedral structure. You see the structure, it is octahedral structure. So today I explained you sp3d and the sp3d2 hybridization in the case of the elements of the third period. Now in my next video, I will explain you sp3d3 hybridization. So if you like my videos, please share and subscribe. Thanks very much.